The Dark Ages are coming. The Dark Ages are coming.
Sounds like fear-mongering? It would be, except for the fact that this time, the fear-mongerer is actually right.
A wise person once said, "Man is the only creature stupid enough to knowingly and deliberately poison his own environment." And humanity has recently shot itself in the heart. It's bleeding profoundly, and the apocalyptic picture that the ancients once envisioned is not too far from reality.
Our apocalyptic story begins with the Industrial Revolution.
Man has been cutting down trees for a long time, but only with the introduction of production did this resource start being used in the way that it has never been before.
Thus begins the Industrial Revolution. From then on, our story begins to heat up.
What are you doing with that big pile of rocks?
Burning it!
Ooh, we can make money off of this. Muhaha!
The discovery of coal helped bring the Industrial Revolution to its peak at the time, and with it came a consequence that no one foresaw.
As time wore on, producers wanted a more efficient and useful resource to burn, as they found this miracle resource with oil.
Oil represented a turn in the history of our planet. We had a source of energy that was light and easy to handle. At the time of their invention, cars were the ultimate status symbol, and have continued that role for the rest of human history. However, as Aristotle once said, quite often good things have harmful consequences.
Our planet was once a thing of beauty, but with the age of production, we began to change that. Factories started popping up, from the flatlands of the west to the mountains of the east, and finally to the coasts of the south. Each new factory brought with it more pollution, more damage to our world, culminating in the cloud of carbon dioxide slowly cutting away at the legacy of the human race. More CO2 means that less energy escapes our Earth, and thus, more energy stays in our atmosphere, heating us up.
A concept that helps us illustrate these impacts is albedo, which measures the fraction of solar energy that is reflected by a surface. The higher the albedo, the more energy is reflected, and vice versa.
A hotter planet means that more ice sheets from our polar caps and seas will melt, exposing sea, which has a lower albedo than ice, thus absorbing more heat. This increases the temperature of the sea, which leads to expansion. Higher temperatures mean more sea ice melts, and thus the cycle continues.
Together, these processes have caused a rise in sea level that we may not notice today, but we will one day.
On that day, the impending rise of sea levels will flood our most iconic cities. The Victorian architecture and irreplaceable monuments of London will be gone. The iconic structures and unforgettable landmarks of New York City, loved by all, will be gone. Peggy's Cove, one of Canada's most famous landmarks, will disappear under the water. We will be left with a world that has lost the memories of its once illustrious past.
However, that day has not come, and there is still much we can do to keep the spark of humanity alive.
If we don't reduce carbon emissions, the overall impact can be detrimental, devastating our infrastructure, employment, and health safety.
So how does reducing carbon emissions help? Well, the carbon that most factories release is in the form of CO2. CO2 contains two bonds with the carbon atom, forming double bonds with oxygen.
By releasing more carbon emissions, the greenhouse gas traps more heat within the Earth, working against the albedo effect, since the heat trapped by the carbon emissions results in icebergs melting, which reduces the amount of heat reflected.
Now, the light incident from the sun produces a range of frequencies that are generally absorbed by the energy levels of the atom, which is a phenomenon known as resonance. When the energy levels of the atom absorb this energy, it radiates this energy forth in all directions, with some energy going into space while some going back to the Earth.
The energy that goes back into the Earth is converted to heat energy, which is what contributes to the enhanced greenhouse effect. Hence, by minimizing the amount of CO2 atoms in the atmosphere, one can slow down the heat trapped by carbon atoms because of resonance, thus preventing the melting of sea ice and rising sea levels.
While prevention is the best measure, other solutions should be looked at. For instance, building huge walls. Though this response might sound childish, it actually requires a lot of thinking. For instance, if smooth walls are chosen as an artificial barrier between sea and land, the reflected water will interact with the incoming waves to create turbulence. Instead, a chiseled wall would act as a better solution, as it will scatter the reflected waves.
Go.
Furthermore, the materials, height, and distance from sea levels should all be evaluated when constructing such walls. Some disadvantages of this solution is that it ruins natural landscapes, with the initial natural habitats ruined by artificial interference.
In addition, this could result in interference with sea life, as many animals follow wave directions to determine their location. Finally, this is an expensive solution, with a wall being built conservatively requiring approximately $3 million to construct a wall around Manhattan Island.
Another innovative solution is using our natural habitats to our advantage to create a natural barrier with plants such as the mangrove. Mangroves are plants that grow in water with their roots extending far down to the sea. Instead of using soil, the mangroves use nutrients from water to survive.
By planting mangroves into regions of low coastal regions, the overlapping of roots in the water will create a natural barrier that will dissipate the energy of incident waves. According to research, over 70% of the energy incident by water waves is absorbed by plant mangroves prior to reaching shores. Though there are no reliable statistics on how much impact a mangrove can absorb from a tsunami, this natural form of barrier is far more expensive and far more subsidized than walls. However, growing mangrove forests will require a great deal of monitoring and evaluation in order to make sure that the forests are expanding, and could require a lot of money to keep repairing mangrove forests after disasters, as well as requiring a huge amount of time to grow.
Sand engineering is also another effective way of using nature to combat rising sea levels. To prevent flooding, a large reservoir of sand is shaped into a man-made peninsula and is placed in regions not too far away from coasts or shores.
The sand is prone to erosion and hence results in the sand being eroded back to the coastal regions, making the sand levels at the coast higher than before. The waves distributing the sand throughout the shore, filling in the sand levels, thus preventing a rise of sea levels.
The Dutch were able to expand their dunes, with the water distributing an adequate amount of sand to a wide expanse of 2.2 miles at 5 feet high. Though this may seem effective, it has several drawbacks, such as requiring huge amounts of sand, accurate engineering, while at the same time not as divisive in impeding water flows as walls. As the water impact is still able to penetrate through the grains of sand.